class, it's time for your next video. We are covering section 1, 2, order of operations and simplifying expressions. So today what I'd like for you to be able to do is use order of operations to be able to simplify expressions. So to start off with, we're just going to talk a little bit about some operations that you've used before, but it's just been a while. So let's go ahead and get started. The first thing, we're talking about a power. So when we have powers, it's going to be a big number at the bottom called the base, and it's going to be risen to some power called the exponent. So an example would be 7 risen to the third. So our question is, what does the 3 in the above example represent? Well, this 3 is up top, so that is the exponent. Okay, now to kind of break that down even more for you, an exponent tells you how many times to multiply a number by itself. So this would be 7 times 7 times 7. I took the number and I multiplied it by itself 3 times. Now, another word that I want you to know is the word simplify. I'm going to highlight it for you because it is important. Simplify. To simplify a numerical expression, it means to replace it with a single numerical value. Now, I know many of you guys know this, but sometimes people, after a while, they start saying stuff and they forget what they mean. Numerical, notice how the first part, it sounds like number, right? Numerical number. Numerical just means number, basically. It's an adjective to describe number. Now, simplify does not mean solve. Solve is different. So solve versus simplify. Solve means to find a value. So we don't know what something equals, but we're trying to figure out what equals. Simplify means, how do I say it? To basically combine it into one part. Into a single term. Usually it's a single term. Okay, so simplifying, we are not changing the value of anything. We're not solving because there's no equal sign. We're just taking it and adding and subtracting things together. Solving is when we don't know a value and we're trying to figure it out. So there is a difference between these two words. All right, so in this first example, we are going to simplify 7 cubed, or 7 to the third. Well, instead of writing it 7 to the third, we want to figure out what that single numerical value is. So 7 to the third is equal to 7 times 7 times 7. Then you're going to need to get your calculator out and you're going to have 343. So let's go ahead and do some you try it problems. 3 to the fourth. To rewrite that, that is going to look like 3 times 3 times 3 times 3. At that point, if you need to get your calculator out, that's fine. That's going to get you 81. And that's your answer. It's okay if you have decimals. I'm going to do my best to get you guys to be not afraid of decimals or fractions anymore. They are just fine to use. So this is 0.2 risen to the fourth. So that means 0.2 times 0.2 times 0.2 times 0.2 4 times. You're going to want to get your calculator for that as well. I already worked mine out ahead of time. So this is going to equal 0.0016. And we're done with that. Notice we brought it all the way down to one number. So instead of having like 0.2 and a 4 in our expression, it's just this one value. All right, now we have 2/3 cubed. Well, this is 2/3 times 2/3 times 2/3. Well, when we're working through this, when you multiply fractions, I know you haven't been working with fractions for a while, but if you need to remember, when multiplying fractions, just multiply the top of straight across and multiply the bottom straight across. So I will put a little note over here for you just to remind you. When multiplying fractions, just multiply straight across. Now, the reason I say that is because people start getting confused. When do I cross multiply? And when do I just multiply straight across? Just do regular multiplication when you don't have any other operations going on. So it's just, all we have is multiplication, so that's what we're going to do. So for the top, we have 2 times 2 times 2, which is 8 in the numerator. And then for the bottom, we have 3 times 3 times 3, which is equal to 27. We will check to see if it can be simplified, but it can't be. So 8 over 27 is our final answer for that. So these are just, this first part was just to kind of remind you about powers and exponents. Now we're going to put it all together where we might have more than one operation, because in all of these, all we've had is exponents that we had to worry about. But we can have multiplication and subtraction and exponents and all that type of stuff in our problems. So order of operations, I put stars next to it and all of that because it is really, really important, okay? Order of operations, this is huge. We're going to be using this for the whole year. Okay, so with order of operations, there's a couple ways that can kind of help you remember. I prefer PEMDAS, that's what I say. And this is just like a little acronym to kind of help you remember it. This is what I prefer, PEMDAS. Or we have, please excuse my dear Aunt Sally. So the P corresponds and the E corresponds, my with the M, and so on and so forth. What do these represent? So I'm going to write that out over here to the side. The P represents parentheses or grouping symbols. E represents exponents. M for multiplication. D for division. A for addition. And S for subtraction. Okay, move that up a little bit more. So I'm going to break this down just a little bit more for you. So the first step, we work these out in order. The first step is to perform any operations inside grouping symbols such as, okay, so grouping symbols, that's what the parentheses represents. So a parenthesis, or a set of parentheses, I should say, which looks like this, is a grouping symbol. You might also have curly brackets. Those look like this. That's considered a grouping symbol. You might also have square brackets. Which looks like that. All of these work and function the same exact way as parentheses. There's no difference between them. The only reason we do this is when you start getting really, really big, complex problems, it gets confusing if you have parentheses inside of parentheses, inside of parentheses, inside of parentheses. So we start using different shaped grouping symbols to kind of help us just keep it a little bit more organized for our own self, okay? Also note, a fraction bar also acts as a grouping symbol. So what that means is, say that you had, I don't know, 12 plus 8 over 4. 4 times 2. That's just made up. This fraction bar right here, you keep everything on the top together and you keep everything on the bottom together. So if it helps you, you can just go ahead and put a set of parentheses around both of those things to help you remember. So that is important. A fraction bar acts as a grouping symbol. After you take care of all of your groupings, and if you have more than one, start from the inside and work your way out. You're going to simplify your powers. So your powers are your exponents. After you do all that, you're going to multiply and divide from left to right. Don't go through and do all of your multiplication and then all of your division. You do both of them at the same time, starting on the left and going to the right. The same thing for addition and subtraction. So, whichever method you prefer to use to kind of help you remember that is fine. Either the Please Excuse My Dear Aunt Sally or PEMDAS, whichever. But that's very important that we get that order correct. Let's go ahead and put that into practice on the back of this. All right, so I'm going to go ahead over here. I'll write out PEMDAS to kind of help us remember to follow that. Okay, so the first thing is parentheses or grouping symbols. So in this first problem, we do have a set of parentheses, and inside of it is 6 minus 2. So I'm going to do that section. 6 minus 2 is 4, and then I carry everything else over. Don't lose things. People do sometimes don't copy stuff over correctly, and then that gets them mixed up. So this is now 4 cubed divided by 2. We took care of all of our parentheses. It's okay if you don't rewrite them. Next we have exponents. Well, we do have an exponent in this, and it's 4 cubed. So if we need to write it out, that's fine. That's just 4 times 4 times 4, which is 64. So I'm going to rewrite that 64 divided by 2 now. Our last step is just to divide that, which is going to equal 32. And that's our answer. All right, moving on to problem B. We have 0.5 cubed. Well, first we have parentheses. We can't do anything to this 0.5. It's just a plain number. It's as simplified as it can possibly go. So we're going to leave that and move forward to exponents. Well, yeah, we can do an exponent because that's risen to the third power. So if you need to rewrite it out as multiplication, that's fine. Or you can put it straight into your calculator. And when you do that, you are going to get 0.125. All right. Moving on to problem C. We have 5 minus 6 over 3 squared. Okay. Just because you don't see parentheses, remember we do have a grouping symbol in this, which is the fraction bar. So I'm going to go ahead and put parentheses around the top because that fraction bar means we need to keep everything together on either side of that fraction. So 5 minus 6 is the first thing I'm going to do. That gets me -1 at the top over 3 squared. I'm also going to take care of the 3 squared now. So I have -1 over 9. I can't simplify that anymore. If you took -1 divided by 9 and got a repeating decimal, I mean, I guess that'd be fine. But if you can't simplify a fraction, then there's really no need to divide it out. Just leave it the way it is. So we have -1/9 for that. All right, we have a couple more you try problems, but because we're doing a video, I will just go ahead and do it with you. So we have 4 times 7 minus 4 cubed divided by 2. We don't have any parentheses. So moving on to exponents. We do have an exponent, 4 cubed. So we're going to carry everything over. 4 times 7 is still staying there. Minus, well, what is 4 cubed? We already did it up here, so we can just get our, we already did it over here, so we can just get our number, which is going to be 64. And then carry everything else over. Now we have multiplication and division. Work that from left to right. So we have multiplication here. We have division here. So 4 times 7, that's going to be 28. Carry over your minus sign. 64 divided by 2, which is 32. Okay, now we have 28 minus 32 for our last step, and that's going to give us -4. All right. We have 2/3 cubed, and am I correct? We did. We already did 2/3 cubed on this side, so we can just carry over 8/27. So we already know that because we solved that problem on another section of our notes. So that is going to be 8/27, and leave it like that. All right. We have one more type of problem that I want to show you today, and it's called evaluating algebraic expressions. So evaluate. When we evaluate algebraic expressions, don't let that word kind of trip you up and think, what does that mean? All it means is you're going to be given a value for some letter, and you're going to substitute the value in. So we're just plugging it in and then solving. So here's our example. It says, what is the value of the expression for x equals 3 and y equals 2? So we know the value that x is supposed to be, and we know the value that y is supposed to be. So instead of having x squared, we're going to put in its value, which is 3. So this is going to become 3 squared. So I'm going to rewrite this whole thing, just substituting in my numbers. So I have 3 squared plus 3 minus 12. I'm just carrying that over. Divided by, y squared. Make sure you're using the y value now. So that's going to be 2 squared. So there's just one little extra step where you know what's supposed to be in there, so you just rewrite it with the numbers. So that's all we're doing. Now we're going to use our order of operations, and I'll go ahead, write that out one more time. PEMDAS, or please excuse my dear Aunt Sally. And we don't have any sets of parentheses, so now we're moving on to exponents. We do have 2 sets of exponents, so we're going to do them both at the same time. 3 squared is 9. Carry down everything else. Don't lose it. Otherwise, you're going to change your value. Then we have multiplication and division. We do have division right here, so I'm going to go ahead and divide that. So I have 9 plus 3 minus 12 divided by 4 is going to be 3. Now we're just left with addition and subtraction. Do it from left to right. So 9 plus 3 is 12. 12 minus 3 is 9. So that is going to be my final simplified answer. Moving on to our next and final problem. So B, what is the value of the expression for x equals -2 and y equals 5? So keep that in order. We need to know what we're substituting in where, okay? So our x's need to be given a -2 and our y's need to be given a +5. When I start substituting in negative numbers, I like to put parentheses around it so I know that the number is negative and I don't lose track of it. So you don't technically have to do that, but that's what I do, and it seems to work pretty well. So our first step is to rewrite this. So we have -3 times -2 squared minus 7 times -2 plus 5 squared. So yes, do we have parentheses? We do, but it's just a plain number in each of them, so we don't need to worry about simplifying anything inside of our grouping symbol. Now we move on to exponents. We do have 2 sets of exponents. Only the -2 here is being risen to the exponent, not the -3. We have to do this in order. If we multiply that together first, then we'll be going in the wrong order and we'll get the wrong answer. So first, we take negative 2 times negative 2. Well, remember, two negatives multiplied together gets us a positive. So we have negative 3 times 4. 4 is I took negative 2 squared. Negative 2 times negative 2. Minus 7 times negative 2. I'm just carrying all this down. Plus 5 squared, which is 25. Okay. Now I'm going to do multiplication and division. Well, I don't have any division, but I do have two sets of multiplication. So I have negative 3 times 4, 7 times negative 2. So this is negative 12 minus, I just carried this minus sign down, 7 times negative 2. A positive times a negative gets me a negative. So I'm going to have negative 14 plus 25. Remember, when you subtract a negative, it becomes plus a positive. And now I just have addition and subtraction straight across. So negative 12 plus 14 is positive 2. Positive 2 plus 25 is equal to 27. And we're done with that one. All right, our very last problem we're going to work through today is this one. And notice we have a cubed in here, we have a squared, we have x equals 0 and y equals 1. So let's rewrite it out. 0 cubed minus 5 times 1 minus 2 times 1 squared plus 6 times 0. Alrighty. First, we have our exponents to take care of. Well, 0 cubed is just 0. 0 times itself is still 0. And 1 squared is just 1. So we have negative 5 times 1 minus 2 times 1 plus 6 times 0. Now we have our multiplication. Negative 5 times 1 is negative 5 minus 2 times 1, which is 2, plus 6 times 0, which is just 0. We're now at negative 5 minus 2. Well, when you have a negative number and you take some away from it, it becomes more negative. So this is going to be negative 7, and we're done. All right, I hope that those order of operations and substituting values in made sense to you. If you have questions, then make sure that you bring them to me tomorrow when we're working